All right, so this is just a quick review of Unit 8. I am only doing a review over the lessons before spring break. And then if you have any questions, you can always talk to me on through Zoom meeting or the email. But we're gonna do a quick review here. Right here is 8.1. We are graphing exponential functions. I have given you two examples. Y equals 2 parentheses 8 to the 9 to the x plus 3. We need to determine, is this growth or decay? Remember, we determine that by what is in the parentheses or what has the exponent. If it is less than 1, like 8/9 is, this is decay. Remember, we also need to determine what our A value is. Well, our A value is 2, and then transformations. If the plus 3 is with the exponent, that means we are doing the opposite of left or right. So this is left, and we're gonna move it 3 spaces. So when we're graphing, we need to remember that A says we're technically starting at 2. But I need to now move it based off of my transformations. This says I am moving it left 3, so I'm gonna go over left 3. That is where my initial point is. We know we have a horizontal asymptote, and it's happening at y equals 0 because we didn't move it up or down. And now we need to determine decay. Decay means I am ending up at 0. So we are starting up above and moving down. Okay. Our next one, we have y equals 1.9 to the x minus 2 minus 3. So first off, our 1.9 is what is with the exponent, so it is larger than 1, so this is growth. There is not a visible A, so that means A equals 1. We have a minus 2 with the x, meaning we need to go right 2, and the minus 3 here says we're moving down 3, okay? Remembering all of our transformations. So once again, as we are graphing, our A says we should start at 1, but transformation says I need to move right 2 and down 1, 2, 3. So we have our original A point here. We also need to remember that at -3, we have our horizontal asymptote. So our horizontal asymptote is at -3. Make sure you know our horizontal asymptote, it's important. The last thing we need to do is draw. Well, this says growth, meaning we are ending in infinity. So we start at 0 and we end into infinity. Make sure you remember how to graph. That is a big indicator of this unit. Okay. All right, our next problem, I think, is one of your guys' absolute favorites. And that is writing an equation, so for a y equals a times b of x equation for when we have points 1, 32, and 3 and 8. So I think a lot of you, this is where some of us struggled, which is fine, but we're getting a review. So remember, for this one, what we need to do is, since we've been given our 2 points, we need to make 2 separate functions. So this first one says we have a y of 32. We have no idea what a or b is, but our x is 1. We're going to do the same thing with 3, 8. So we're going to say 8 equals a times b to the 3rd. So our first step is to solve for a, and we're going to do it with the one that has the easiest exponent, and that is 1. So we're going to divide by b, and we're going to get 32 over b equals a. Then we're going to plug a back in, knowing what it is, to the other equation. So we're going to get 8 equals 32 over b times b to the 3rd. And this allows us to solve for b. So we have b cubed over b. So what that is remember, it's 3 minus 1. So we're going to be left with 8 equals 32b squared. We're going to get b squared. We're going to get 8 divided by 32. That is the same thing as 1/4 equal to b squared. We square root both of them. We only need the positive, so b equals 1/2. So that gives us B. Now we have B. We can plug back into our equation for A, which is 32 divided by 1/2, which means we are taking 32 times 2, and we're gonna get A to be 64. Because again, this is the same thing as saying 32 times 2 over 1. So we have our A and B values. So our full equation now is y equals our A value of 64 times our B value of 1/2 to the x. So we wrote our equation. Okay. Remembering all those steps, again, you should have your notes from last time, and you can always contact me to see if you have any questions. So as a quick reminder, remember when we're doing word problems right now, we should use the formula of A equaling A naught 1 plus R to the T. So this is the amount we're getting, this is the initial amount, this is our rate and our time. Also remember, certain words might indicate subtraction, like decreases, okay? So please remember that formula. Okay, so we're gonna now move on to our problem of 4, where it is 100, 5x plus 2 equal to 1,000, 4x plus 6. So a lot of you remember this is slightly different. This one is same base. We want to solve by the same base. Remember your reviews, I keep them in order. This is just in order going through. So this is solving with same base. So I'm first going to notice that we have 100 and 1,000. I believe the same base to be 10 just because it's so much easier. 100 is the same thing as saying 10 to the squared, but because I have an exponent, I had to do my power rule saying that I'm going to multiply it. The same is going to go for 1,000, except it is 10 to the third, and remember power to a power, so we're going to multiply it. Now that we have the same base, we can say they cancel, and we're going to be left with 2 times 5x plus 2 equal to 3 times 4x plus 6. So this is just solving with multi-step equations. We're going to distribute. We're going to get 10x plus 4. Distribute again, 12x plus 18. I'm going to move my x's over. So I'm going to get 4 equal to 2x plus 18. Subtract my 18 to get negative 14 equal to 2x, and then divide by 2. So x is going to equal negative 7. So remember, same base is slightly different than what we've been working on the last few weeks. It just says we need to get to the same base to cancel them out. Okay, I'm going to do another one with same base just as a quick review. So we're going to do 9, 2x minus 5 equal to 27. So I have 9 and 27, and I can't get 27 to 9, so our next bit is 3. So 9 is 3 squared, and we're going to have to multiply it by 2x minus 5, and 27 is 3 to the third. We've gotten same base, so we can cancel. We get 2 times 2x minus 5 equal to 3. So it's just solving once again. We distribute to get 4x minus 10 equal to 3. I'm going to add 10 to both sides. We get 4x equals 13. Divide by 4 to get x equals 13 over 4, or its equivalent of 3.25. Okay. Again, this is all just quick review, making sure you remember how to do this. All right, one more problem and then a reminder. I don't remember what problem you're on. I think that was 5, so 6. When I say evaluate, it means give me a number. So we got log 3 of 1 over 81. So we need to remember how to evaluate. That means I need to get this to be the same base of that base. So 81 is 3 to the 4th, right? So this means we can do log 3 over 1 over 3 to the 4th, but we still can't do it because of that 1. Remember, if it's on the fraction, it is negative, so this is actually log 3 to the 3 to the negative 4th. Once you get that log with a 3 and a 3, your answer is just negative 4. Remember how to do those. Another evaluate, just as a quick reminder, if you have log of 4 to the squared, what this is just indicating is we need to change this base to help match that base. So 4 is the same thing as 2 squared, and we still have the 2. Remember, this is not a 0 exponent, it is a 1. It is a 1. So what this indicates is since this and this are now the same, we have a numerator of 1 and a denominator of 2. Just because you are solving for this does not mean that it's going to be fluctuating like that. Okay? As another quick reminder, if you have log to anything, let's say 37, and it says 1, there is no other way to get an answer other than realizing, I'll work this out for you, there's only one exponent that gets this to work. So we can say this is equal to x and we can solve. So we're gonna manipulate this to exponential, saying 37 to the x equals 1. There is only one exponent that works to make anything equal 1, and that is x being 0. So just as a quick reminder, okay, if you have any log with a base to the 1, your answer is 0. And as our last reminder, that lovely formula of when we have a log with some a base with a b equal to c, I can transform this to exponential, saying a to the c equals b. Okay, so remember, these are just transforming from logarithmic to exponential. So that was just a quick review over 8.1 through 8.4. Make sure if you have any questions, you let me know, and you should be good to go for this week.